Welcome back, everybody. We are once again squandering the precious years I could have spent looks-maxing, making this video game instead. It's an open-world, emergent gameplay RPG with ultra-violence and a simulated ecosystem. Except we're not actually simulating an ecosystem yet, we're just sort of generating sticks and rocks, but today, folks, all of that changes. I'm Code for Broke, still at least a few months away from a public mental breakdown, so let's enjoy these few precious moments together while we still can. Now, if you watched my last video, you know we spent most of it speeding up world streaming, so I'd love to leave the subject behind and go straight to the interesting stuff, but I can't. Because one keen-eyed viewer noticed an FPS hitch in the last video during this scene with a lot of trees. And since my growth plates have fused and peptides can't make me 6'5", what else could I do with my life but fix it? See, last time we limited the number of props spawning in a frame, so you'd expect it not to make a difference if there's 10 or 10,000. And yet, it does, because the problem is actually not the spawning of the props, but deleting them. It was finally time to implement object pooling. Object pooling mitigates the expensive process of creating and apparently destroying objects by releasing them into a pool to be reused, turning them off instead of deleting them, and then repositioning them and turning them back on as a new section of the world is loaded. It's far from a novel idea, it's more like baby's first Unity performance improvement. But regardless, I hadn't done it yet because, I feel sometimes it's good to leave a little something on the table. And so I implemented it by grouping props by their shared components, specifically whether their collider is a box, sphere, or capsule. This way we only need to alter some values rather than add or remove components when we recycle an object. And this works because aside from the type of collider, the vast majority of the prop objects are composed of the same components. Now, I have no idea what's going on in the background of the engine to make this happen, but apparently just changing an object's parent transform when you do it 20,000 times in a single frame is a pretty expensive operation. We're talking like a third of the compute in the frame the chunks load. I swapped the prop spawning from chunk space to world space, removing the parenting entirely. The next big performance hog is the nav mesh, the three-dimensional shape that represents the computer's pathfinding area. Since we're loading and unloading multiple chunks simultaneously, we end up doing a lot of extra work due to the fact that we're making separate calls to modify the nav mesh. Each of these calls has to prevent pathfinding briefly while the navigation area is modified, and internally run functions to add connections between tiles. It's highly parallelized within the job, but since no two jobs can modify the nav mesh at the same time, each of the chunks ends up blocking each other. Simple fix was to create a class to manage the nav mesh of all chunks, instead of having each chunk handle it themselves. When a chunk is loaded from disk, we'll send the nav mesh data to the manager, and listen for an event that fires when all chunks in the scene have been loaded successfully. Then we can assemble the entire affected area and make all changes at once. And this ended up being considerably faster. It's nice to have something actually work out how you imagine for once. Now that the number of different chunks we're loading no longer has a huge impact on performance, we can make even more gains by changing their size. Rather than loading 3x3, so 9 total, large chunks at a time, instead we can split roughly the same area into 5x5 smaller chunks, loading 25 in total. And this means we load smaller amounts of data more frequently when the player is moving, resulting in a more consistent computational burden. Now we can maintain 60 FPS navigating through the entire game world. The next thing we ought to tackle is how completely f***ed the NPCs are. They float around weirdly and they spaz rotate randomly in combat and just generally look pretty low class. This is all more or less a hangover from when this game was 2D once upon a time, so I had to rewrite a lot of the animation code from scratch to better suit the third dimension. I stopped characters from being able to rotate during a swing as well, which made combat feel a lot more impactful. And in the future, I plan to have a mid-swing rotation speed stat-based, so characters with more dexterity sort of feel that way. Now before we move on to the next stuff, it's about time this game had a name. Naming a game, as it turns out, is pretty hard, especially for a long-running project like this. You see, you come up with something that at the time really seems like a good idea, like for example, my friend Brian's huge juicy ass. And so you sit thinking about this name while you work on your game, maybe even for a year or two, and then one day you think to yourself, hey, my friend Brian's huge juicy ass maybe doesn't describe even one single element of this game accurately. Maybe it's not the right choice after all. I would have really regret paying $100 for a Steam page titled My Friend Brian's Huge Juicy Ass, and honestly, I would have felt like a f***ing idiot. But finally, I found one I really liked, and that feeling didn't fade over time. So now, for some reason, in a Scottish accent, the reveal, bastard sword, bastard sword, bastard sword, bastard sword. It's called Bastard Sword. I hope people like the choice. There is a Steam page up now, but man, the media on there is not doing the game any favors with the AI slop allegations. Now, currently, in the game world, we've got some goblins appearing randomly and wandering around in circles. It's only really an ecosystem if we're simulating f***ing germs or something, so I'd like to add some new behaviors. The goblins exist in isolation, so we'll start by giving them something to respond to. I re-implemented the day-night cycle, giving the nights extreme darkness. I love it when nights are truly dark in video games, so lights are actually necessary, but I'll probably vary this in the future to emulate moon phases. With darkness, so too must there be light. So I created this handheld torch and threw it into the game using an existing animation I made for blocking, layered to override the left arm. This way it kind of works out of the box with any other one-handed piece of equipment. Next, I assembled a few goblin houses from old models, including one with a second floor to help test the limits of the nav mesh generation. Then I made a dirt texture to project onto the ground beneath them so they don't look quite so out of place, and I returned the homes to the world generation. Next iteration will sort out a better way to place these things, but for now they're just sort of spotted all around. Now that we have homes again, we need a solution for the roof mesh blocking the camera, since we're going to be going indoors. I created this effect that limits the maximum camera distance when the player is inside a building and makes the roof invisible. This isn't necessarily the final effect, but it'll do for now. Also let this effect trigger when navigating near windows so you can have a peek inside. The next step was to alter the NPC spawns to belong to a specific dwelling when the world is generated. Having a designated home will be important for programming the computer's behavior, and it's essential for the idea that these things aren't just spawning randomly off screen, they kind of exist in the place for a reason. Next, I dusted off this old bed model I made forever ago and had them spawn inside the goblins' homes. I feel like I haven't mentioned it in a while, so just to remind you where I stand, I find goblins absolutely disgusting. I reversed the stand-up animation to hack in sleep quickly. You can probably see where this is going. The NPC's brain works by sorting through a list of goals, which they add to or remove from in response to things they observe. As the NPCs become tired, the priority of their sleep goal will become increasingly high until it's the most important thing they have to do, at which point they will. As they sleep, the opposite happens, and eventually they're spurred awake. Now we can watch these fellas, named after my Patreon subscribers, get some well-deserved sleep. Night-night, fellas. Of course, they'll need something to do during the day. To handle this, we have to stop looking at the goblins as individuals, and instead examine how collectively they form a community of freaks, basically a subreddit. When a goblin village is generated, we'll create roles based on the available infrastructure. Dwellings will create some roles to guard critical resources, and additional roles to explore the map in search of others. Then I created a standing version of the torch, just to give another activity for the computer intelligence to consider. When it gets dark, an available nearby member of the community will start the torch fire, and at the end of the day, they'll go home to sleep. Now, in a time-lapse, we can see a little bit of activity. As we layer in new factions and races in the future, eventually we'll see fights break out and equipment changing hands. Honestly, I'm stoked to be where we're at right now because the next stuff in the pipeline is going to get really exciting. This might actually be a legitimate video game sometime soon. And I've got a plan to do something a little crazy in order to speed up development massively, so lend me your faith, friends. Thank you for watching, especially the people on Patreon. Peace out, everybody.